Unit 1, Part 2, okay? This was where we really talked about, well, when do you choose the correct method, when to make your life easier. We did this so we're not sitting here scrambling and doing the quadratic formula every time when there's a much more obvious way to find the solution. Now, by all means, the quadratic formula will always work, but this is a standard that we need to know, and this is very good information for you to know how and when to choose the appropriate one. After that first section, then we went into complex numbers, okay? Simplifying, adding, subtracting, multiplying, and dividing by the conjugate. So let's go ahead and get started with some examples. Choosing the best method. All right, I kind of left using factoring blank because I wanted to make sure my vocabulary matched with what we told you in the packet. I don't have it with me, so I apologize, but I can go ahead and tell you when you're factoring, when you see that factoring, it will be obvious, it should be obvious that you can quickly take that number, whatever it may be. Okay, if you watch my first review, we had x squared plus 5x plus 6. The 6 can be factored into 2 and 3, and that quickly adds together to give you 5. That was a very obvious method of solving that. You have very nice numbers. Everything will work. You might have to take the common factor out, the greatest common factor, but everything will be very nice and tidy. Okay, using taking the square root. This is when you're either in vertex form, and I apologize, I didn't write that. I should have. I told my students I know vertex form is key. Okay, if you don't know what vertex form is, it's a times x minus h squared plus k. If it's in this format, or in more layman terms, your bx term is missing. Remember the quadratic ax squared plus bx plus c equals 0. It's when this term is missing. That is when you take the square root. Okay. Now the next method is using completing the square. The completing the square, you have two qualifications. Your leading coefficient is 1, and then your bx term is even. If it's not even, then you cannot complete the square. It must be even, okay? So you have to watch out for that. You also need to look for, when you're completing the square, if your leading coefficient is 2, 3, 4, what have you, see if you can factor out that term from each of the one in the parentheses, okay? That way you can get a leading coefficient of 1 and you can use the completing the square method. You cannot complete the square unless your leading coefficient is 1 and your middle term is even. Your b term is even. Last but not least is the quadratic formula. We use the quadratic formula when all other methods fail. This is your last resort. I told my students that you're going to have ungodly numbers. Now, that was not acceptable to write on a test. Yes, some of you wrote it on the test. You need to understand that all other methods failed, and you have a leading coefficient that is greater than 1 that cannot be factored out, and you also cannot factor. There's no nice way of getting there, okay? So please be mindful of when you use completing the square. All right. Now, after that, what we're going to do is we're going to kind of break down, and you're going to go through, and you can look at examples. Excuse me, let me go back. Okay? You can go through examples. You can go back to the examples from Unit 1, Part 1. Watch that video, look through those examples if you are confused or want to see one of those examples. But other than that, that was really what we did, okay? Now, the second part to Unit 1, Part 2 was simplifying complex numbers. In this example that I'm showing you, when you're simplifying I to whatever power you may have, you have standard I procedures, okay? I to the first power. Okay, I'm going to go ahead and write this out. Whoops. I don't know why it made me go to the next slide. I'm getting finger happy. Okay. Let's try this again. There we go. if we have I to the first power, well, I to the first power will always remain I, okay? Now, some of you started there. Some of you might have started with something before 1. What comes before 1? Well, I to the 0 power comes before 1. Anything to the 0 power, please, at this point in time, if you said 0, go ahead and get it in your brain. That's not right. I to the 0 power will always be 1. Anything to the 0 power will always be 1. Say that to yourself if you got that wrong. Please, okay? Now, after this, we now have standard rules. I squared is a -1. You use I squared the most, in my opinion, when multiplying, especially when multiplying your irrational numbers, these complex numbers. When you're multiplying them, that's the one that you use the most. Please know that I squared is equal to -1, okay? After that, I cubed is a -I. And then I to the 4th, that's when it restarts, and that becomes 1, okay? So notice we have 0, 1, 2, 3. And then at 4, it restarts back to 1, okay? So it was safe to say that every multiple of 4, okay? What is that? 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. All of those are multiples of 4 that when divided by 4, you're going to get a whole number, okay? So we can always say that that is going to be equal to 1, all right? So far, so good? So based off of that pattern, yes, this is a pattern. Based off of this pattern, we can now predict and simplify all powers, whatever they may be, that are the powers, whatever I is raised to. Whatever I is raised to, whatever power, we can simplify it, okay? So in this first example, I to the 21st power, I told you, and I don't know if your other teacher told you, but you can look at it of figuring out what factor, what multiple, 21 divided by 4 is equal to what number, okay? In this case, we have 4 times 5 will give you 20. That gives you a remainder of 1. Now, in my class, I said if you have a remainder of 0.25, okay? That tells me you have I to the first power. And that tells me it will simplify down to merely I. All right? Now, 35. 35 divided by 4 will give you 8.75. All right? 35 divided by 4 will give you 8.75. 0.75 is a remainder of 3. Okay, 8 remainder of 3, or 8 3/4, all right? If we're talking about fractions, I don't know if you taught fractions, but that's something else you can pay attention to as well. All right, so if we're looking at I to the 3rd power, we're looking at a -I. All right, so that I to the 35th power simplifies down to simply -I. All right, this is also what I just said. That is simplifying complex numbers. If you need more help on that, please ask. But this is very important. Again, the biggest thing that you're going to be watching for is this right there, okay? So let's go ahead and move on to adding and subtracting imaginary numbers. Okay, with imaginary numbers, you have to remember on that first slide, I don't know if I told you, but we have the standard form of A, oopsies, I'm getting used to this still, guys, I apologize, of A, see, I'm just messing up, A Standard form of a plus bi. Since we have an imaginary solution, it's going to be the last thing that we look at. So it always needs to be the last thing you write. It doesn't matter which way it comes into play. It doesn't matter where it is. You have to put it towards the end. You have to put it at the end. Okay? Math is very orderly. You have to have order to what you're reading, or you're going to be lost. All right? So, to add, subtract, if you look at this example right here, I gave you a very basic example, but something that we struggle on because if you notice, I went ahead and just gave you a subtraction one. We use this and we combine our whole numbers, okay? We combine like terms. But notice there is this minus sign, okay? This minus sign you can't ignore. You have to, yes, have to distribute this minus sign into the parentheses. And that is why I changed my signs to plus for, I didn't write a step. But that's why I changed my signs in this. Watch. 2 plus 4i minus, that becomes a plus, 6 plus 3i. All right? I rearranged to show you that I'm combining like terms. I put my whole numbers, my real numbers, together, 2 minus 6, and I put my imaginary numbers together, 4i and 3i. I kept my signs to make sure. I made a mistake, you guys. I don't know why I did that, because even in my notes it was there, but this is a minus 6. I apologize. Very much so. That is my fault. But I put my stuff together. I apologize. So, with that being said, 2 minus 6 is a negative 4, and then 4i plus 3i is a 7i. I apologize. Make sure you know and not follow my rule. Make sure you understand that this is a positive 6 right here. When you multiply a negative and a positive, it's a negative. Signs are tricky, and even I get them confused, clearly, even though I've done the work. So that is how we add and subtract imaginary numbers, all right? If you need more practice on that, please let us know. We'll give it to you. Okay, multiplication. We use the box method, the area model, to multiply these two binomials together. If you know FOIL, use your FOIL method, all right? But we taught, here at Marietta, we have taught this area model. So we set it up, 2 minus 3i on the top. Okay, I was asked by my students, does it matter where it goes, whether on this side or this side? And it does not. Okay, just make sure they're on opposite sides of this outer box. Okay, so 2 minus 3i and then 3 plus 2i. Now we multiply. This 6, okay, this 6 right here, we got from 2 times 3. And then this negative 6 we got from 3. Ooh, that is wrong. This should not be a negative 6i. What should this be? This should be a negative 9. Let me see if I can figure how to do this. How to erase while I'm doing this. But this should be a negative 9. I, to be more exact. This should become a negative 9i. All right? And then this is 4i. This works. And then negative 3 times 2 is a negative 6i squared. So that is good. So all of that is good. This one is bad. So what we're going to do is I'm going to scratch out my work. You'll notice on your PowerPoint, if you're following along with your notes, I have corrected this. I will correct this. I'm simply just going through this again. 6, negative 9i, plus 4i, minus 6i squared. Okay? I'm running out of room, so let me make this smaller. okay? Just know that's of 6i squared. And when we go to rewrite this, we combine like terms. 6 minus 9i plus 4i becomes a minus 5i. It does not become a minus 5i squared. Treat it like it's an x and combine like terms. Don't overthink this. But now we have to simplify at the end the 6i squared. We know that I squared is equal to a negative 1. So I'm going to go ahead and substitute that value in for I squared. So this becomes 6 minus 5i plus 6. A negative 6 minus 1 is a positive 6. So now we're looking at 12 minus 5i. Okay? Remember, I made a mistake. This becomes minus 5i. And that's how you solve using a binomial. Okay? Multiplication. All right. Again, your PowerPoint will be corrected. Your notes will have the correct version of it. I apologize. I'll make sure I go back and fix that. The next slide, division with complex numbers, all right? Division was more difficult because you had to multiply by the conjugate, okay? So we had two different examples. One was simply with the I, okay, in the numerator, the negative I in the numerator. So you had to make sure you understood that when multiplying by the conjugate with this negative I, you can multiply it by I, and you'll get a negative I squared. Why is that important? Because if we remember, I squared gives you a negative 1. Not an I, not anything like that. We want that I squared. We need it. We need to rationalize that denominator. Okay? So, for this example right here, I'm just going to talk you through it. We multiply by an I. What you do to the bottom, which is the denominator, you must do to the numerator. Okay? And if you notice, what they did was they distributed this I into each term in the parentheses. I added the parentheses. Please make sure you add those parentheses when you're working this out for the test or for practice or what have you. So we have 5i plus 4i squared all over negative I squared. Well, simplify it, and they kind of hit a step from you. They know that a negative 1 is a positive 1. So that becomes 5i minus 4. All right? It's not in standard form. Okay? So you have to rewrite it and put it in standard form. A plus bi. It doesn't matter the 4 is negative. It has to come first. Negative 4 plus 5i. Okay? This one becomes more complicated. All right? 3 plus 2i, I'm going to look at this one right now. 3 plus 2i all over 4 minus 5i. Multiply by the conjugate. The conjugate is when you change the sign of this right here to a positive 5i. Okay? You have to change the sign. Now, all right? When you do this, you have to use the box method. If you know FOIL, please use FOIL. But if you do not, come over to the side and show your box method. And you're not going to just do it once. You have to do it twice, okay? You have to use the box method twice, all right? So the first one is going to be for this 4 minus 5i over 4 plus 5i. Now, I do not have enough room to go through that, but that is how you would set it up and do it, okay? As you work through it, you'll get your like terms, combine them, and move them along. Simplify, work all the way out till you get to the bottom. 2 plus 23i over 41. Now, remember, you have to have all real numbers first, and then your bi term, okay? So this denominator must be separated with the real and your complex. That is why it is written as they wrote it in that yellow box. If you need more help on this, please do those examples on the test. Come ask for help. All right. The next part, well, that's it. That was Unit 1, Part 1. So I'm going to go ahead, Part 2. So now we've done that. So I'm going to stop, and I'm going to start a new video.